Hello, for data communications and network one class today, อาจารย์อุษณา will continue on the high-level data link control protocol. Okay. In the operations of HDLC, we have three phases: initialization, data transfer, and disconnection. In the first phase of initialization, the either side of the communication, like you have A and B, okay, either A or B can request, okay, the connection by issuing one of the set mode commands, such as set normal response mode or set asynchronous response mode. Okay, think about if you want to call someone, you have to dial up, you have to dial their number, okay, in the phone, okay, to call them. So you are kind of initialize the call, something like that. In the data communications, it's the same. Okay, you initialize the connection. Okay, and this command, okay, is used to request initialization and specify the mode. Okay, since you can have either any of the three mode. Okay, and you also specify whether you have 3 or 7-bit sequence numbers. Okay, there are two lengths for the sequence number that you can specify in the HDLC. And the length of the sequence number will affect your window size, okay, in the sliding window control, right? As we have talked about before. If you dial someone, okay, like you send the request, okay, and the other side, the receiver accept this request, the receiver will send unnumber acknowledge or UA, okay, unnumber frame, which is unnumber acknowledge frame back. Okay, this is accept the connection. But if the other side does not accept the connection, okay, it will send disconnect mode, which is also the unnumber frame, okay, but it's DM frame. Okay, so when you want to call someone, okay, think about this, the other end, okay, the receiver can either accept your call or not accept your call. They can decide. Okay, so this is whether the receiver send back the UA or the DM. The next phase is data transfer. Okay, and both sides can begin, okay, by sending the information frames. Okay, if they have data to send, okay, so they send it with the information frame or the iframe, and it will start with frame number 0, and it will have the frame number 0 is the NS, okay, which is the send sequence number. If you have 3-bit sequence number, it's 0 to 7, okay, because you have 3-bit, right? So it's going to be like this. So 0 to 7. If you have 7 bit, okay, so you have go to 7 bit, okay, then you have 0 to 127 for the frame number. Okay, the NR is the receive sequence number, which is the same as acknowledgement. Okay, after you finish a data transfer, we will have examples later. Okay, then we can disconnect. Okay, so either end can initiate the disconnection, sending the disconnect frame. Disconnect frame is also a number frame. Okay, now the other end, the other side must accept, okay, must accept the disconnection, okay, and it have to reply with the UA or a number acknowledgement frame back. Okay, like if you want to hang up, okay, one side hang up, then you no longer have connection, so the other side have to accept this disconnection. Okay, but at the when you dial up to accept the call or accept the connection, you can either accept or not accept it. Okay, but disconnection, you have to accept the other side disconnection. Now we look at examples of the operation. Okay, I will have many examples to try to make you understand what is going on, and I will use a simple diagram. Okay, so that it's easier to see. Okay, for the first one is a setup and the data transfer examples. Okay, link setup, disconnection. Okay, so you have session A and B. The time direction is here. A send initialize the connection by set asynchronous balance mode. Okay, to B, but it doesn't get anything back. Okay, doesn't get UA, a number acknowledgement back. So it wait until timeout. Okay, so it send request again. Okay, now B accept, so B send UA a number acknowledgement back. Then this is become data transfer here. Okay, after it finish sending, it send this connection, which is again a number frame. Okay, then we have to accept this, so we send UA. Now the data transfer is in the second picture. Okay, the two-way data exchange or two-way data transfer between A and B. Okay, so if A have information to send to B and B also have information to send to A, okay, A send I frame with frame number 0. So this is A number, frame number, okay, and this is ACK number. Okay, since A hasn't get anything back from B yet, so it start with ACK 0. Okay, so it send frame number 0 and ACK 0. When B receive this frame, okay, B also have information, so B send I frame, okay, with frame 0. This is B frame number. Okay, it's ACK 1. ACK 1 because it's received frame number 0 from A, so it's ACK 1. Okay, I have received correctly your frame up to frame number 0 and I'm expecting frame number 1 as the next frame. Okay, then A send I frame, and since B ACK 1, A has sent 0 before, so now it send number 1, right? And this is also connecting to the fact that B expecting number 1. Okay, it's ACK 0 already, so A can send frame number 1. A send number 1. Actually, A can send anything in the window of A. I will draw it in detail in a little bit. Okay, look at the simple diagram first. This is a space-time diagram, but it's the simple one. I will draw the more detailed one in a little bit. Okay, and since it received frame number 0 from B, okay, so it's ACK 1, B frame. Okay, then since A is not running out the window, A just starts sending, like, the window now start from frame number 1. Okay, so it can send frame number 2, number 3. It depends on the window size of A, but it can still send number 2, number 3, number 4. Okay, even though it use 3-bit sequence number. Okay, and again I will draw that in a little bit more detail. Okay, anyway, go back to this. A send I 1 1, then A can send I 2 1 because this is the next frame and it's still in the window of A. So it send I 1 1, I 2 1. Okay, so the first frame, the second frame of frame 1, A frame 1 and A frame 2. Okay, then B receive this. Okay, so B ACK 3. Okay, because it have received correctly frame number 0, number 1, number 2, so it's ACK number 3. Okay, ACK number 3 is send information frame, and B frame, okay, before this is what? 0. Okay, so now it can send number 1. Okay, the last time it sent number 0, so now it send number 1, and this also linked with the ACK 1. Okay, from A. Then A send A get this. Okay, it's ACK 3 and A hasn't sent number 3 yet, so it sent number 3. Okay, but it know that B has received up to number 2 correctly. Okay, so now it can send number 3. Okay, and because it's received number 1, frame B number 1. Okay, so it ACK 2. Okay, then B receive frame number 3, so it's ACK 4. It get ACK 2 from A, so it send frame number 2. ACK 2 from A, so it send frame number 2. Okay, become like this, and then after it send number 2, it can also send number 3 because still in the window. Okay, haven't received anything more, so it's still act 4. Okay, then A has nothing else to send, so A send S frame, which is only acknowledgement. Okay, S frame RR4, because it has received correctly up to number 3, so it's expecting number 4. Okay, so this is like positive acknowledgement. Now okay, so this is the, I'm trying to put down some information. Okay, maybe not as detailed as I talk about, but it should help. Okay, that it in the slide. Now I want to show you in more detail when I talk about the window. Okay, so usually we draw it like this. Okay, before. So we have receive, transmit, right? And first A send I information frame 0, 0. Okay, so it receive like this. Time is this way. Okay. Then B have B want to send I01, right? So which is the acknowledgement of frame A, but also the information frame of frame B. Okay, so it send, then A send to frame. Okay, so this is I11, I21. Okay, and then this one will send act back. Okay, like this. This would be the I13. Now let's look at the window. Suppose I use 3-bit sequence number. Okay, suppose I use go back in. Doesn't show here, but assume that I use go back in. So window size equal to less than or equal to the b minus 1, less than or equal to the 3 minus 1, which is 7. So let's use window equal to 7. Window of A and window of B, usually we use the same size. Okay, so window of A is 7, window of B is also 7. Now look at A window. So you have frame 3-bit, right? You have like this. Okay, this is a frame in the window. Sorry, this is the frame number. Okay, that I want to send. Suppose, okay, continue like this. It will repeat after 7, so it becomes 0 to 7, 0 to 7. But the window size, okay, so it starts 0 to 6. So at this time T1, window is here. Window is 0 to 6. Then at this time T2, okay, it get act what? I01, so it's act 1. Act 1 means that the window can move to start from number 1. So this is at time T2. Okay, the window move. Okay, so it become like this. When you get more acknowledgement, sorry, at this time T3, it get act 3, so it can move like this. Okay, so this is the window at time T3, okay, of A window, and whatever frames are in the window you can transmit. Okay, so this is kind of more details related to what we have talked about before. Okay, next example is for BC condition. Okay, suppose A and B are sending like this. Okay, this is the time. So B send, supposed to have, okay, dot. Now the frame that we focus on is information frame of B, okay, and frame number 3 from B, okay, and act 0. When A receives this, okay, A says that I act your frame, okay, so I act 3 here, but I'm not ready to receive any more frames at this time, so it send INR. This is S frame, INR frame, receive not ready. And B wait, and then B say, are you ready now? Okay, so B send S frame again, okay, to, this is also S frame, okay, to A, and it send RR0 because it act 0 here, okay, because it haven't received anything from A, so it's X0, the same as before, but it set the bit to P to 1, okay, P/F, okay, for final bit is set to 1 to ask the status, okay. Then A say, I am not ready, receive not ready for, this is my answer to you, so I set that bit, the same bit, okay, to 1, but it's called final, this is your response. Then B wait, okay, ask again condition or the status of A. A say, oh, okay, I'm ready now, so RR4, and this is final is answer to poll, okay. When A is ready, then B can send the next frame, okay. Before it sent I 30, so now it sent I 40, okay, which is frame number 4, okay. Again, this is I'm trying to type something that is like important here, but it's the same as similar to what I'm talking about, okay. So B can keep polling A periodically, okay, to ask for the status after A says not ready, okay. Recovery means that if you have something wrong, okay, with the transmission and you want to recover the transmission, okay, what can you do? Okay, do I have 2 examples here, reject recovery and timeout recovery. Okay, for reject recovery, this one, since you can see reject here, so it means it's go back in, okay, use go back in AIQ. Okay, suppose dot A send information frame number 3 and X0, and then it's send number 4, but this one is lost, okay, this means it's lost, so it doesn't, B doesn't receive the frame number 4 from A. Then it send number 5 and B receive number 5. Now B knows that something is wrong with frame number 4 because it send receive number 3 and then receive number 5, right? So it doesn't get number 4. So it send reject number 4, okay. Then A have to send again from for number 4, so you send I40, I50, I60. This is depend on the window, okay. So you can continue sending depend on the window before you're getting acknowledgement back from B. So this go back and AIQ, you have to send number 4 again because it's reject 4, right? And all following frames, even though number 5 you have sent before, it will not be stored, okay. B will ignore it. Number 5 will have to receive frame in order, okay, for go back in, okay. So you can think about if it's selective repeat, what will happen, okay, which is not in examples here, but you can think about that, okay. Timeout recovery, another examples. A send I to 0, okay, to B, okay. B send RR3 back, okay, to acknowledge this. This is S frame, okay. A also send I30, okay, to B, and it's lost, okay. Because it is lost, it doesn't get acknowledgement of frame number 3, okay. It's just get acknowledgement of frame number 2, right, that it has sent. So it's wait until timeout. So it's ask for status. What is your status? I have received ready your frame number 0. Expecting number 0 from you, and this is my question, okay. What is your status? B say, oh, I am received ready 3. I'm expecting frame number 3. This is your answer, okay. So since it say RR3, it means that B hasn't received number 3 yet, and it's already time out, so A send number 3 again, okay. Then B send RR4, okay, to respond that it have acknowledged it have received number 3 from A, Okay, so this is examples of the recovery. Okay, and this is the trying to type here. Okay, reject recovery and timeout recovery. Okay, so now this is the end of HDLC protocol. As I told you before, I will try to focus on the main protocols, okay, such as this is the basic, okay, very old, but it's the basics for our other protocols was very popular in the past, HDLC, and it's easy to understand, okay, in the operation as a good start, okay. Then we'll talk about the inland local area network. We talked about Ethernet, and also in the internet with the I, okay, internet. We'll talk about TCP/IP protocol, okay, which is the protocol that we use in the internet, and hopefully after we study the main protocols, okay, when you have to study other protocols, okay, updated new protocols, then they are similar in many ways, okay. Protocol is just like the way that you will talk to each other, okay, one side to the next, to the other side, okay. So you just agree on how do you read the bit sequence, okay, and you will find, okay. So this is not difficult, but there's quite a lot of details, okay. So thank you very much.